We are made of meat. We eat meat to survive. And to process that food, our bodies secrete a specialized liquid engineered to dissolve wheat. Given that reality, why doesn't this fluid instantly burn a hole straight through your abdomen? To understand the threat, we have to look at the math. This is a pH scale, measuring acidity from an alkaline 14 down to a highly acidic 0. Down here at the extreme bottom edge, you find the most corrosive industrial liquids on Earth: solvents, battery acid, fluids that chew through metal. And right next to them, landing between a 1.5 and 3.5 on the scale, is human gastric acid. At this concentration, the fluid inside you right now can break apart complex proteins, dissolve solid bone, and even disintegrate razor blades if given enough time. Logically, housing a liquid this destructive should kill a human within hours. For us to survive our own digestion, the body executes a flawless biological containment protocol. Down at the microscopic level, the actual wall of your stomach is incredibly vulnerable. It is made of fragile, exposed tissue. To protect those cells, the body builds a wall. This diagram shows a cross-section of the stomach lining, where a dense, highly specialized mucus layer forms a physical boundary between the tissue below and the pool of acid above. The lining constantly secretes this thick gel, pumping out material to ensure the barrier never dries out or thins away. This barrier is also actively chemical. The body weaves bicarbonate, an alkaline compound, directly into the mucus, creating a distinct neutralization zone right at the top edge. When droplets of gastric acid sink down and make contact with this bicarbonate-rich layer, a chemical reaction occurs. The acid instantly dissipates into harmless byproducts before it can penetrate any deeper. The stomach maintains its integrity through this active chemical force field, ensuring the lethal fluid never makes physical contact with the organ it serves. But no chemical shield is perfect. Even with the mucus barrier fully engaged, microscopic amounts of acid constantly slip through the cracks. When a breach happens, the result is instantaneous. The unprotected stomach cells violently rupture and die the second the acid touches them. To counter this ongoing damage, the body triggers a secondary failsafe, an aggressive, relentless cycle of cellular regeneration. This chart shows normal human cell life cycles compared to stomach cells. While normal cells might last for months or years, stomach cells reproduce at such an extreme speed that your body completely replaces the entire stomach lining every 3 to 4 days. We know exactly how vital this fast-paced turnover is because we can observe what happens when the system breaks down. Certain triggers, like chronic stress or NSAID painkillers, or an infection from H. pylori bacteria, can thin the mucus shield and slow down the rate of cell regeneration. When the acid eventually overwhelms the weakened defense, it starts eating directly into the tissue wall, carving out a deep, inflamed crater. This is a gastric ulcer, the physical manifestation of an organ digesting itself. Human survival relies on a delicate biological engine, where the speed of cellular creation must continuously outpace the rate of chemical destruction. Zooming out from the microscopic level, this mechanism forces us to evaluate our own evolutionary engineering. A stomach operates as a perfectly calibrated, high-stakes war zone of ongoing defense and repair. The human body is a continuous biological event, a system that persists only because it never stops replacing its own parts. The physical stomach processing your dinner tonight is, on a cellular level, entirely different from the stomach you had last week. This relentless process of tearing down and building back up allows us to safely harness dangerous chemistry to navigate a hostile world. Your body is actively rebuilding itself every single day. To keep rebuilding your own understanding of human biology, hit subscribe to The Explainer and join us for the next video.